And you're going to have to enter the formula for this on your study sheet because it's not on the formula sheet. Okay. Right, so expected value, it's an application of probability that involves the likelihood of gain or loss. So it's basically going to tell you whether you're going to be making money or losing money. It has to do with money every time. Okay. It is stated as a dollar amount, so your final answer will be a dollar amount. Expected value is relevant in business, insurance, and many other situations in daily life. Okay. I have to say this, that the expected value is only accurate in the long run. So basically, it would only be true if you were to, for example, play a game enough times, like hundreds, thousands of times. It doesn't really tell you what's going to happen on any single event. Okay? And here is the formula, and it is somewhat scary, but I think you can handle it, okay, once I explain it to you. So make sure you highlight this and you add this to your study sheet. Highlight that and add it to your study sheet. Make a note of that. Okay. So basically, you must answer expected value is going to be a dollar amount as well. So make sure you add that. And is there anything else? I'm just going to say it right here because you're going to copy this to your study sheet. If the expected value, if it's positive, right, you should play. If it is 0, it is a fair game. You're not going to win or lose money in the long run. And then if it's negative, don't play. Then you shouldn't be playing because you'll lose in the long run. So as a player of the game, if you get a positive answer out of this, it's a good thing for you. You're going to win money. But I'm going to put in brackets, it's bad for the host. Because if you win money, if you're the client and let's say you buy a lottery ticket or it's at a fair, you're playing some sort of silly game, and you keep on winning money, you as the host, the owner of that machine, you're losing money every time. Okay? And so if you get a negative expected value, you shouldn't be playing, but this would be considered good for the host. Okay? So it's kind of like you have to read it carefully. This I would definitely have on my study sheet. So I will label this expected value. Formula. Okay? I would have everything that I just put in this box on my study sheet. Obviously, have a smaller version of it. Okay? And look what it asks you to fill in. It's the probability of winning the first prize. Let's say there's like various prizes. So I'll tell you the probability of that happening. It could be a decimal percentage or fraction. Doesn't matter. Whatever happens, we're going to turn that into a decimal. You multiply it by whatever that prize is. So let's say you win $1,000 if you get drawn. Plus the probability of winning a second prize, if it is there. Sometimes there's only one way to win. You would ignore this part. But if there's a probability of winning the second prize, you multiply that by the money that you would get for that second prize, and that would continue for as many prizes as there are to be won. Minus the cost of playing at the very end. You're going to subtract how much you spend to play the game. Okay, so that's our strategy here. Here is the expected value having positive, 0, or negative. One more time explained. So if it's positive, gain expected for the player, good for player, bad for host. I just repeat it one more time. If it's 0, it's considered a fair game. You break even. It's up to you want to play. Like if you play 1,000 times, you're going to end up with $0 additionally in your pocket. So if you have 20 bucks and you play 1,000 times, you're gonna probably leave with 20 bucks in your pocket. Like, you're not gonna have gained, you're not gonna have lost, okay? If it's negative, you're gonna lose, but it's good for the host. Anyways, the expected value is the average amount. Here's one more time. Expected value is the average amount you're expected to gain or lose per game or per bid. Now, there's one little twist to this. We usually involves games of chance, but sometimes it has to do with like a contract. If you're familiar with if you know someone that owns a business, okay, you sometimes have to put in a bid. You have to put in a bid as to like, I want to get this contract, but you're not sure that you're going to get the contract. So with government, for example, before your company gets the contract to build a road, you're going to have spent money on getting our engineers, on getting like all the people that you need to kind of lay out the proposal. And it costs thousands of dollars sometimes as a company. That's technically like the ticket cost to play the game. When we get there, you're going to understand, you're going to see what I mean. So sometimes, most of the time it's games, but sometimes it's also a contract. And let's try the first one here on page 70. You cannot miss expected value. You will not miss it. The question on the exam, on the test, it will say calculate the expected value. You know it's this one, okay? A game at a summer fair consists of drawing marbles from a bag. The bag contains 10 red, 30 yellow, and 60 white marbles, okay? So that'll be 100 total, right? Since we're dealing with probability, it's probably a good idea to figure out your total if you need to. Sometimes it just flat out tells you, so you got to watch out. If you draw a red marble, you win $25. So this is what I call the first prize. If you draw a yellow marble, you win $7. So it's less, but it's still there. That's my second prize. If you draw a white one, you get nothing. You lost. Okay. It costs $3 to play the game. So this is the cost. Right? You identify all of that. And now let's look at our formula. Expected value. Let's write it out the very first time. Probability times first prize plus probability times the second prize. Is there another way of winning? Is there a third prize or a fourth? If there had been a third prize, you would continue this. But there isn't. So we just go minus cost. So here we go. The probability of winning the first prize is it's found by getting how many reds there are. There are 10 red marbles out of the 100 that were in there in total. So we take that, we multiply it by the first prize, which is 25 bucks. Just like that. Then we go plus the probability of winning the second prize, and the probability is found by determining how many yellows there are in the 100. So we have 30 yellow marbles out of 100. So you take that probability and you multiply it by the $7 that you would be winning. And last but not least, minus $3. You just go minus 3. No probability for that last one, okay? And now you grab your calculator and you do one at a time. So I'm going to focus on this one here first. So 10 divided by 100. I'm going to hit equals. I'm going to multiply that by 25. So that gives me 2.5. Okay? So you go 2.5 plus, then you do that second part here, 30 divided by 100 times 7. That's $2.10, or 2.1. Minus 3. And now you're ready to just add and subtract, right? So it's 2.1 plus 2.5 minus 3. So add and subtract. What does my calculator show me, positive or negative? It's positive. So it'll be positive 1.60. It's dollars, so you must have the 0 there, 60. It can't just be 0.6. That'll be a rounding error. Okay, they're very picky about that. So it being positive, positive means gain. Okay, so that's important there. You don't have to put the plus in front. That's fine not to do it. But that's basically my final answer here. So if the question B is just underneath is asking, should you play this game? The answer would be yes. Okay. So let's just go down. Should you play this game? Justify referring to the answer above. And this is where they're really picky. You should say yes, comma, because the expected value is, what do you think should come after that? The sign, positive, exactly. That's all they care about. If you say, nah, you shouldn't be, or you should be playing because the number is pretty big, you're not going to get this mark. So I will highlight the fact that is positive. So you have to say yes because it's positive, or you would say no because it's negative if your answer indeed ended up being negative. So that's why, that's how you justify. If you were to play this game 125 times, how much would you expect to win or lose? We determined you're winning already. So you'd go 125 times, multiply that by $1.60. That'd be $200 that you would have gained at the end of the day. We're expecting that. We're not saying guaranteed for sure, but somewhere in that ballpark. D, should the fair offer this game? You would say no, okay? No, since a positive expected value means that the player wins and the host loses. So you will lose as the fair. You will lose money if you offer this game. So not a good idea from that perspective. Okay, so before I want you to try it right away on 71, but before you go for it, sometimes it is way simpler than this. It's way simpler quite often. So I'm just going to tell you what I mean by that. Let's go back up to this question here. Make sure you look before you start, otherwise you're going to ask me this probably anyways. Let's say this question did not mention anything at all about the yellow marbles winning you anything. It just said the red marble wins you something, everything else you lose. Then you would this whole thing would have just come down to, right, 10 red out of 100 times 25, you get 2.5. And then you would have just subtracted the 3 right away. There is no second way to win. So you have to read carefully and use this formula appropriately as needed, okay? So go to page 71, try that one, and also try 72. I will give you the answer to the question on 71. You're supposed to get 50 cents. That's supposed to be positive. So write that down in brackets. And for page 72, so write down 50 cents for 71, right? For page 72, I'm just going to go over here. That is supposed to be negative $3.35. Okay? So give that a try, see how that goes. I will go over it in a bit. You have everything you need, right? So just making sure you're okay. A 6-sided die is rolled. Even number gets you the prize. Odd number, you don't win anything. So there's really just one prize. One prize. Okay? Exclamation mark. So for the expected value, your evens are, there's 3 options out of 6, right? And we multiply it by $3. Then we go minus the cost, which is $1. That's it. That's all this has to it. Okay. So this is basically 3 over 6 is half times 3 is 1.5 minus 1. If you subtract this, you get positive 0.50. If you want full marks, this has to have a 0 there. Okay, so that's your expected value. Should you play? No, because it's only 50 cents. Right? It is positive. Yes, since the expected value is positive. Let's say you got a negative answer. That's wrong, by the way. Then I would expect you to say no, since the expected value is negative, right? I would want you to be consistent. If you were to play this 75 times, how much would you expect to win or lose? You would win. You determined that already. 75 times 0.5, that's $37.50. Okay, that's the idea there. 72, let's try that one. Please don't just type all of this in one shot, and then if you get the wrong answer, you lose a full mark. Take your time, tell us how you broke this down. So in this case, we're told that there's 2,000 tickets sold for this raffle. Okay? Each raffle costs you $5, each ticket. Okay? So here is the distribution. Like 1 ticket will win $2,500, 4 tickets will win a second prize, and then the third prize, right? So first, second, third. So there's 3 prizes. Make sure you write this down and make sure you add notes that I'm giving here. So the expected value here is 1 over 2,000. That's your probability of winning the very first prize times $2,500. Then you go plus. There's a 4 out of 2,000 chance that you win that second prize. And you win $75 in that case. Plus, there's 20 out of 2,000 chances of getting the third prize. You only win $25. So you're almost done. At the very end, I'm just going to do this once, minus the $5. This is the cost, right? Just do that once. Don't subtract it from every single one of these if you do that separately. So then you figure this out. 1 over 2,000 is a really small number times 2,500 is $1.25. Okay, so 1.25 plus 4 divided by 2,000 is this. You multiply that by 75, you get 15 cents. plus 20 divided by 2,000 times 25 bucks, you get 25 cents. And last but not least, the minus $5, that's the cost of playing. You don't have to have a dollar sign, just at the very end you have to have one. So here we go. 125 plus 0.15 plus 0.25 minus 5 is negative $3.35. Okay? Here's my negative. So very important to have that sign correct, otherwise you are not getting the full answers. Should you play this game? No, since the expected value is negative. That is the, I'm telling you, if you don't mention this, you can write 3 pages worth of explanations and they're not going to give you the mark. They want to see positive or negative. That's basically bottom line. Nothing else matters. If you play 98 times, will you win or lose? You will lose. 98 times $3.35. That's a whopping $328.30. That's like playing lottery. You probably will lose over your lifetime, but you still do it, because if you hit the jackpot, you could be rich. Okay. One more question for you to try. Go to page 73. I'm going to ask you to do 74, actually, question 4, right there. And if you're done 4, try 3, but I'm basically just going to focus on 4 right now. On page 74, question 4. It says expected value, so you can't. Okay, I'll do 4 with you guys. We want the expected value. There's only one prize, which is getting the contract, which is worth $200,000. Okay, so in this case, there's a 10% chance of winning the contract, right? Like winning the bid. So 10% is 10 over 100. Or you can go 0.1, that's up to you. Okay, 10% chance is 0.1 or 10 over 100. Whichever one you use is going to give you the right answer. So we win $200,000. If we do win, there's a 10% chance of that happening. Then we go minus the cost to draft the bid, to prepare the bid. That's it. One way to win. And then the cost of entering that game, basically. So you get, I didn't do it this way, hold on. Oh yeah, 20,000, I knew that. Minus 5,250. So your expected value is 14,750. Okay. So this one would definitely be positive, so you should bid because you expect it to win in the long run. Okay.